Welcome to the Decoding the Dark podcast. Take a deep breath. Settle into wherever you are right now. Let the noise of the day fade away. If you find yourself drifting off tonight, that is perfectly fine. The quantum world is much like a dream anyway. But before we begin our journey, if you enjoy these late-night explorations, please leave a like on this video. And if you'd like to support the show, you can buy me a coffee using the link in the description below. In our first episode, we looked at a coin. We talked about how classical computers see the world in absolute certainties. Heads or tails. 0 or 1. A world built on solid ground. But we also realized that underneath that solid ground, there is a hidden ocean. A place where the coin never truly lands, but spins endlessly in the dark. Tonight, we are going to dive into that ocean. We are going to explore the strange, almost magical rules that make quantum computing possible. We are going to talk about the weirdness of the universe. Part 1. The Infinite Box. Superposition. Let's begin with a famous thought experiment. You may have heard of Schrödinger's cat. Imagine a simple closed box. Inside this box is a cat and a deeply unpredictable quantum mechanism. Until you open the lid, classical logic tells us the cat must be either asleep or awake. It has to be one or the other. But quantum mechanics tells us a different story. It whispers that until you open that box, the cat is not asleep and it is not awake. It is somehow both at the exact same time. This state of being multiple things at once is called superposition. In our daily lives, this makes no sense. You cannot be sitting in your chair and walking outside simultaneously. But for a qubit, the heart of a quantum computer, this is its natural state. It is a 0 and a 1 and everything in between, all suspended together like a mist. And this is where the true power lies. If you have one ordinary bit, it holds one piece of information. If you have 2 bits, they hold 2 pieces. It is a slow, steady, linear climb. But qubits, they grow exponentially in the dark. 1 qubit holds 2 states. 2 qubits hold 4. 3 qubits hold 8. By the time you gently link just 300 of these qubits together, they are existing in more simultaneous states than there are atoms in the entire observable universe. 300 tiny, fragile qubits, holding the vastness of the cosmos in a single, quiet breath. Part 2. Spooky action. Entanglement. But superposition is only half of the magic. To build a quantum computer, these qubits must talk to each other. And the way they communicate was so bizarre, so unsettling, that even Albert Einstein refused to believe it. He called it spooky action at a distance. Today, we call it entanglement. Imagine for a moment 2 small spheres of light resting in the palm of your hands. They are twins, born from the exact same energetic event. Because they are entangled, they share a destiny. They are no longer 2 separate things. They are a single system, separated by space. If you were to take one of these spheres and leave it here on Earth, and you took the other sphere, placed it on a rocket, and shot it all the way to the far edge of the Andromeda galaxy, they would remain connected by an invisible cosmic thread. If you gently tickle the sphere on Earth, the sphere in the Andromeda galaxy laughs instantly. If you change the spin of the particle here, the distant particle shifts its spin at the exact same moment. Not a second later, not at the speed of light, instantly. Distance means nothing to them. Space, as we understand it, is an illusion to entangled particles. They are two halves of the same soul, dancing in perfect rhythm across the silent void. In a quantum computer, we use this invisible thread. We entangle qubits, allowing them to share vast amounts of information instantly, processing complex puzzles together without ever exchanging a single physical wire. Part 3. Whispers across space. Teleportation. Because of this deeply hidden connection, entanglement gives us another incredible ability: quantum teleportation. Now, let your mind rest. We are not teleporting people. There is no flashing light beaming you onto the deck of a starship. We are teleporting information. Imagine you have a secret, a deeply valuable piece of information. In the classical world, to share that secret, you have to write it down, put it in an envelope, and send it across the world. But along the way, a thief could intercept the envelope, read the secret, and put it back. You would never know. Quantum teleportation changes the rules. Using entangled particles, we can take the state of one qubit, its exact identity, and instantly transfer it to another qubit miles away. The original information vanishes from the sender and immediately appears with the receiver. It does not travel through the air. It does not travel through a cable. It simply disappears here and emerges there. Because it never travels across the space between, it is completely unhackable. There is nothing for a thief to steal in transit. If anyone ever tries to listen in, to break the quantum lock, the delicate spell shatters. The entanglement breaks, the information turns to noise, and you instantly know you are being watched. It is the ultimate, unbreakable whisper across space. Part 4. The act of looking. The observer effect. And that brings us to the final and perhaps the most mysterious rule of the quantum realm. The universe knows when you are watching. In physics, this is known as the observer effect. It means that the simple act of looking at a quantum particle changes how it behaves. Remember the spinning coin? The mist of superposition? As long as you are not looking, a quantum particle is a wave of pure potential. It flows through all possible paths at once. It is everywhere and nowhere. But the very second you measure it, the very instant you cast your gaze upon it to see where it is, the wave collapses. Imagine walking into a dark, pitch-black room. In the darkness, the furniture is floating, shifting, swirling around the room in a fluid dance. But the instant you click on your flashlight, everything crashes to the floor. It becomes solid, normal. Nature allows the magic of multiple realities to exist, but only in the dark, only when we are not looking. When we demand an answer by measuring it, the universe forces the particle to choose. It drops the disguise of infinite possibility and becomes a simple classical bit, a 0 or a 1. This is the greatest challenge of building a quantum computer. We have to coax these particles to do massive, impossibly complex calculations in a state of absolute isolation. If a stray photon of light, or a tiny fluctuation in temperature, or an observer accidentally interacts with the qubits, the wave collapses. The magic vanishes. The calculation fails. We must let them work in the profound, dark silence. Outro. The quantum world is not a distant alien landscape. It is the very foundation of the room you are resting in right now. The chair beneath you, the air you are breathing, the stars shining outside your window. They are all built upon this strange, delicate dance of superposition and entanglement. Classical computers have conquered our visible world, but quantum computers, they are learning to speak the hidden language of the universe itself. Thank you for joining me tonight on Decoding the Dark. If you found peace or curiosity in tonight's episode, please consider leaving a like on the video. And if you'd like to help keep the studio running, the link to Buy Me a Coffee is in the description. Your support means the world to me. Until next time, let your mind wander into the possibilities. Sleep well and keep looking into the dark.